What is up, everyone? Here we go. So today we're talking about simplifying radicals. Now, basically what we're trying to do is we're trying to simplify these radicals. Radical means this little symbol right here. And the way we factor, or we prime, actually the way we simplify a radical is going to be doing prime factorization. Now, if you don't know what that means, it's something that I'm pretty sure you've done before. And it basically looks like this. We're going to take this number up. Like, for example, right here, we're going to take this number and we're going to break it down into all the numbers that multiply to give me 72. So a prime, though, a prime number are these numbers at the very bottom. 2, right? 2 is a prime number because the only two numbers you can multiply to give you 2 is just 1 times 2, right? 3 is a prime number because the only two numbers I can multiply to give me 3 is 1 times 3. But 4, I can do 2 times 2, or I can do 1 times 4. See that, so that can't be a prime factor. So that's what we are doing today. So let's go ahead and write some prime factors out real quick. I know that 2 is going to be a prime factor. 3 is also a prime factor. 4 is not because 2 times 2 is another way to do that. 5 is a prime factor because it's only 1 times 5. 6, no. 7 is only 1 times 7. 8, no. 9. And I'll stop at, oh, actually 9 is not because 3 times 3. And then we'll stop at 11. So those are examples of prime factors. All right, so they can go on forever and ever, but we'll just stop there. So we need to take out all our prime factors. So here's what we're going to do. This 48, I need to break it down into as many prime factors as I can. So basically what I want to know is what are all the numbers that look like this that multiply and give me 48. So let's just do this easy. So the way I like to do it is, I'm actually bringing my calculator, is I like to start with easy stuff. So let me bring up my calculator real quick. Whoa, put it here, bam, bam. All right, so I basically like to ask myself, like, what are two numbers that multiply give me 48? Now, if you don't know, it's super easy. Just try dividing it by 2 to see if that works. So 48 divided by 2 is 24. So I know that 2 times 24 gives me 48. Now I ask myself, do I have any prime factors? So if you look at 2, I can't break up 2 anymore besides 1 times 2, and we don't really want to do that. So it's just, this is 2. We can't break this up. Can I break this up, though? I can, right? What two numbers multiply to give me 24? They're a lot, but I'm just going to do 24 divided by 2 and see if that works. 12. So that means 2 times 12 gives me 24. Okay, cool. I know I can't break up this 2, but I can break up this 12. So 12 divided by 2 again. What gives me that? 6. So 2 times 6. And then can 6 be broken up? I'm going to say divided by 2 again. Yeah, so that means 6 can be broken up by 2 and 3. Now, this is what I mean. This is a prime factorization. What we just found were all the prime numbers that would, when we multiply, when I multiply 2 times 2 times 2 times 2 times 3, if I multiply all those numbers like that, these here, when I multiply them all together, I get 48. Okay, so now that we did that, so here's what I'm going to do. I'm going to rewrite this 48 like this. So I'm going to go this, I'm going to make a huge radical. So if I was to multiply 2 times 2 times 2, there's 4 of them, right? Times 2 times 3, that would give me 48. Okay, now why is this even important? Because here's what happens. Here's a trick. When you have pairs, when I have pairs, we can actually take those pairs out of this radical right here. This is called a radical. I can take pairs out. So like, let me give, for instance, here is one pair. And then here's another pair, right? Here are two different pairs. So now that I found a pair, they come outside of the radical. And when I take them out, they have to be multiplied by each other. So I'm going to take these two pairs out. So what I want you to know is when they take these pairs out, they become 1. All right? So this pair right here, when I take it out, it's 2. All right? So I'm going to rewrite my square root. So that becomes, this one becomes 2. And I have one more that I'm going to take out. It's going to become another 2. And the 3, since this 3 doesn't have a pair, it stays underneath the radical like that. All right, bam. Now that I have this right here, we can multiply these. So this is going to be 2 times 2, which is 4 to the square root of 3. And that is simplified just like that. So I know it's kind of a long process, but that's how we do that. So let's do this next example right here, the square root of 75. Then I'll let you guys do the next one. So I'm gonna write 75 here. Let's do that in orange real quick. So if I do the square root of 75, I really just care about, hey, what are two numbers that multiply to give me 75? Now again, if you don't know, I would just take my calculator out. Now we don't want decimals, right? So I'm gonna try 75 divided by 2. You see how I got a decimal there? I don't like that. So then what I do want to write is, let's try 75 divided by 3. Oops, that's not right. 75 divided by 3 is 25, which means 3 times 25, give me 75. Cool. 3 is a prime number, so we don't want to break that up. I can't break this number up anymore. So then that stays like that. 25, what two numbers multiply? I know 5 and 5. 5 times 5 gives me 25. 5 is also a prime number, so we're done. So we have all the prime factors right here. So then here's a prime number, here's a prime number, here's a prime number. So what does that mean again? That means when I multiply 5 times 3, I will get 75. So let's go back and rewrite this real quick. So if I was to rewrite this, let me erase this. Okay, if I was to rewrite this right here, I could write it as 3. Whoa, chill out. 3 times 5 times 5. That will give me 75. Now what do? We take out the pairs. So how many pairs? Well, yes, I do. Here's a 5 pair. So when I take it out, remember, it becomes 1. So this is going to come outside my radical. So it's going to become 1, 5. And whatever doesn't have a pair has to stay underneath, and then you're done. Just like that. That's it. All right, let's do one more. So square root of 153. Let's see if I can break this up. All right, again, that's a big number. I don't know it either. So then I just use my calculator to figure out, hey, what are two numbers that multiply? If I can get my calculator out, bam. I'm gonna just take the square root real quick to see if it gives me an easy number. So let's see, how do I take the square root? Okay, so we do second x squared, 153. Notice it gives me a decimal. It's not a perfect number. So now what I need to do is I need to try to break it up. So 153 divided by 2. I have a decimal here and I don't like that, right? We don't need a decimal right here. So let's try to do 153 divided by 3. I get 51. All right, cool. So then I get 3 times 51. I know this is a prime number, so I'm really done with this one. Here's a prime number, so I'm done. What about 51? Can I break up 51? 51 divided by 2. Nope, 51 divided by 3. 17, 3 and 17. All right, so then I can break this one up. So this is 3 and 17. I already know 3 is a prime number again. 17, I think 17 is a prime number as well, right? Because it can't be the only two numbers that multiply, so this is also a prime number. So we're basically done. So let's go back and try to simplify this. So what does that mean? When I multiply this times that, I get 153. So let's just rewrite it like this. 3 times 17. All right, then we look for pairs. Here's a pair right there. So what does that mean? That means this comes outside of the radical and it becomes 1. And this has to stay inside the radical because there's no pair. So then there's your final answer just like that. All right, here's the notes in the bottom right there. I want you guys to try to do that one yourselves.